The note keys are in Canvas. So if you miss some of the notes or you need a kind of a refresher, you can always get those notes from the key in Canvas, okay? All right, so if you really want to know what a monomial is and you're like dying to write the definition down, you can just get it off Canvas, okay? But our job is today we're going to add, subtract, and multiply monomials, okay? And a monomial is just a term that's made up of numbers and letters, okay? So it's just something made up of numbers and letters. But there's different rules that go with monomials. And so like sometimes when you add, it has a rule. And when you multiply, it has a rule. And if it's got parentheses, it has a rule. And if you divide, it has a rule. And there's so many rules, you can't keep track of them. Okay, honestly, like I can't keep track of them. So what I used to do is I used to always write the rules down on a sheet of paper. And then when I was tutoring, I'd whip out the piece of paper and look at the rules every time I would get to a monomial problem. Okay, but there's something cooler than that you can use. Hey, and some of y'all had Mr. Flickinger last year, so you probably remember this. Okay, so here it is. Write this on your paper. These are the important notes. So it's P-Man. Do you remember P-Man, Philip? Okay, so this is what P-Man stands for. Okay, so it stands for power, multiply, add, nothing. So power, multiply, add, nothing. Okay, and we're going to think of this P-Man as like a ladder. And when we climb a ladder, we start at the bottom, don't we? We don't just run and jump to the top of the ladder and then climb down. No, we start at the bottom and we climb up, okay? And that's kind of where we're going to start today, all right? So this is what it means. If you look at this problem right here in number 1, it's adding. Now you might be going, that lady is a fool because that says subtract, okay? But adding and subtracting problems are the same, okay? Add means subtract, they mean the same thing, okay? It's kind of like combining like terms. Thank you. So are these like terms? They have to have the same variable with the same exponent. They're like terms, right? Okay, but here's what we're going to incorporate with our P-Man. We're adding these guys, right? So if we're adding them, we're going to do nothing to the x's and the exponent. We do nothing. So if I add, I'm doing nothing. So that means I'm just going to go ahead and combine like terms. 17 minus 25. Philip, I know you have Desmos up. What's 17 minus 25? Okay, so I have -8, and we do nothing to the x except write it down. We leave it just the way it is. We don't change the exponents. We leave it alone. So when we're adding and subtracting, we do nothing to the variable and the exponent. Okay, so when we're adding and subtracting, we do nothing to the variable and the exponent. We do nothing. So check out number 2. Okay, I'm going to check the variables. Are the variables the same? Yep. Do they have the same exponent? Yes. So that means I'm going to combine like terms. And we've done this before. We've combined like terms but we never really discussed what are we doing with the variables and the exponents. Okay, so it's actually just a review. So I'm going to work out negative 23 plus 6. What's that make? Philip, what's negative 23 plus 6? Okay, and since we are adding, we do nothing to the variable and the exponent. So I write down the variable and I leave my exponent alone. We do nothing to the variable and the exponent. Okay, but now we're stepping it up a little bit in number 3, and notice that we've got a letter A to the third, a B, and a C. In order to combine them, I have to have the same exact, I mean exact, variable and exponent. So A to the third, A to the third, B, B, C, C. So that means I'm allowed to combine like terms. So negative 15 plus 6, negative 9. And then we just added, we used the adding integer rule. So we do nothing to the variable and the exponent. We write it down and leave it just the way it was written. We do nothing to the variable and the exponent. Okay, now number 4 is a little tricky because what's it missing? What's it missing, Philip? Huh? Look at number 4. It's missing that 1 right there. Okay, so that's okay. Let's check out our variables and our exponents. X squared, y, y. Okay, they're the same. So I'm just going to work it out. 38 minus 1. And since I added, I do nothing to the variable and the exponent. And if, hey, remember, I can't see these little, I cannot see exponents. So if I read it wrong, y'all correct me, please. Just shout it out. Say, hey, that's a 3 instead of a 2. Okay, so now check out number 5. So I have 2 and a 9, an AB and an AC. Can I combine them? No. Okay, so this is, we can't do anything to number 5 because these guys are not the same. So that is our answer. And if you had a question like this on a test or a quiz, you'd write 2AB plus 9AC. It's already in simplest form. Okay, so everyone good so far? And it doesn't even matter if, like in number 7, we've got a fraction. Because who are we going to call? Desmos instead of fraction busters. Okay, Desmos is our superhero. So I'm just going to use Desmos to do 2/5 minus 1/3. Thank you for typing that in so quickly. What's 2/5 minus 1/3? 1/15, is that what you said? 1/15. I just added or subtracted. So I do nothing to my variable and my exponent. So I have CD squared. Okay, so this is very straightforward. When we're adding and subtracting, we do nothing to the variable and the exponent. All right, but now let's try number 9. So in number 9, this time I have more than one thing going on here. Okay, I've got a bunch of variables and a bunch of exponents. Are you paying attention, Nicole, and doing this on your paper? Okay, so look at number 9. I've got some Y's and Z's. What letter comes first? The Y. Okay, so I'm gonna combine like terms if I can. I've got a Y and a 4Y, a 3Y and a 4Y. They're both the same variable in the exponent. So I can combine them and do nothing to the variable in the exponent. And then I have a 9z minus 3z. So I can work that out and get 6z. So take a 10-second head start and try number 10. Try number 10. Try number 10, Philip. Okay, I'm checking it out. I've got the letter B, the letter A, the letter B. Okay, now poor A has nobody to combine with, so I'm just going to write him down. And my B, I have a 12B and a negative 10B. Those are allowed to be combined because they're the same variable and the same exponent. So 12 minus 10 is 2. Do nothing to the variable and the exponent. I'm just going to write it down. Yes, they have to be lowercase. Okay. Good question. Number 11, are these like terms? I've got a W squared, a W squared, and a W. Even though they're all W's, they are not all like terms because one has a squared and one doesn't. So I can combine things, but only the things that have the same variable and the same exponent. So I've got 13W squared and 4W squared. What does that make? Yeah, 17. I do nothing to the variable and the exponent. I write it down. Okay, and now I can do my plain old W's. So I have a 9W and a minus 31W. And I know someone typed that in. What'd you get, baby? 22? Okay, 22W. So remember, I have to have the same variable and the same exponent to combine them. Same variable and the same exponent. All right, but now moving over to number 12, I've got a squared and an m and n, a squared m and n, but are those two the same? These two guys are not the same because the m is squared in the first term, the n is squared in the second term. So I can't combine those two, but I can combine this guy and that guy, and he's going to go first because remember the biggest exponent of the letter that comes first goes first. Okay, so what is 10 minus 1? 9. M, do nothing to the variable and the exponent. Plus 7mn squared. Okay. Now, here's a little trick, or a tricky one. Okay, and number 13 isn't tricky. It uses the word sum, which what does sum mean? What does it mean? It's addition, right? I think you said that. All right, so it's addition. So we're just going to add those. 16y squared plus negative 5y squared. Okay, so you can write the problem down if you want, or you don't have to. But what is 16 minus 5? 11, and we do nothing to the variable and the exponent. We do nothing to the variable and the exponent. Okay, but when it gets tricky is when we talk about subtraction words. So this word difference means subtract. And we don't change the order. Okay, so difference means subtract, don't change the order. So we're really doing 10x squared y minus 2x squared y. Okay, so we're subtracting, but we don't change the order. Okay, so that's pretty straightforward. So what's 10 minus 2? And then we do nothing to the variable and the exponent. We leave it alone. But sometimes you're going to see a problem like number 15. Okay, so number 15 says, and it has this bad word in it, from. So it's saying, I'm going to subtract 9a from the 15a. That means that 15a or negative 15a is going to go first. It means we're switching the order. So when we subtract from, we're going to switch the order. So what is negative 15 minus 9? Okay, negative 24a. We do nothing to the variable and the exponent. But remember, this says subtract from, and let me highlight my word subtract. Okay, this one doesn't say that, even though it has the same words. This says from subtract. From subtract. So it says from this number, take away that. So we're going to leave it in the same order that it's in. We're going to take away oh, 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 oh. Do you see what I did? It said subtract, and then it said that thing right there. Okay, see? And a lot of kids will say, well, I already wrote the negative down. I don't need to put it again. Nope, we got to put it again. And then as Miss Whitley would say, we got those double stuffed Oreos, right? Okay, so this is going to, boom, turn to plus. And so what's negative 9 plus 2? Negative 7, and do nothing to the variable and the exponent. So there is my answer, which is hard to see. All right, so now these are pretty much kind of a review, pretty straightforward, but turn the page. Okay, so what happens? I love this since I understand it. It's so fun once you know the rules. Okay, now we're going to multiply. So basically the adding and subtracting is just combining like terms. We just have to make sure we have like terms. Okay, so let's come back over here on our side and let's write P-man again. And you know what? This is crazy, but whenever I see this, hold on,